Welcome to another version of At Home with APS. My name is Michelle Groth, and I'm going to be working with my friend Miss Mays.
Hi.
And we're going to do some science and an experiment and some math, and then we're going to play some math games at the end. We hope you enjoy us. Miss Mays is going to start us off by waking up our brain so that we can get ready to learn.
Yes, this is a body wake up. We're going to start with taps. And you stand with your feet shoulder width apart. That means like this. You're not too close, not too far. And you're going to put your arms out, and you're going to gently tap your arms and work your way up and say, good morning. Hello, arm. Then you're going to go to the stinky armpit, and you're going to go, hello, arm. And then you're going to switch. You're going to go to your other arm. Now, remember, gentle, be nice to yourself, but do wake your, say hello.
Hello,
Stinky armpit. Good morning. Let's get busy working. Then we're going to work our we're going to go down. Oops, sorry. And we're going
That would have been me.
wake up our legs, our calves. Say, come on, let's get busy to learn. Let's wake up. Wake up. Give your kidneys a nice little wake up, gentle, but wake them up. And now we're going to, do it. Ooh, we can't do this, but you might want to go,
Be a monkey.
Take a deep breath in and a whoosh out. So now our bodies are kind of ready for some science. And I'd like to give a shout out to my Hodgin Super second graders.
Yes, and my Hodgin Super first graders. We miss you guys.
Yes.
We hope you're watching.
So Ms. Groth is going to teach us about matter.
So welcome. This is my first time doing this, so be patient with me because I am a little nervous. We're going to review some vocabulary that goes with matter. We're going to do an experiment, and then we're going to do a graph, and we're going to write our results. What I do want you to do is go and get a piece of paper or a pen or a marker, something to write with, so that you can do this project with us. First of all, who remembers what matter is? Do you remember what matter is?
I'm a little rusty on it, I have to admit.
Well, let's review it.
Yeah, okay.
Matter is anything that has mass, like a weight, or takes up space, like a volume. So we're going to talk about mass. Mass is the measure that it measures the amount of matter in a substance. So if Miss Mays and I got on a scale,
don't do that. No.
One of us would be heavier than the other. That'd probably be me.
No.
Volume is the amount of space that an object takes up. So everything has volume and mass. Almost everything we have is matter. We use our senses to touch, see, and smell different matters. Okay? So let's discuss the three types of matter. If we look over here at my anchor chart, the first matter that we have is solids. Do you guys remember what solids are? You are right. Solids have a definite shape, they have a mass, and they have a volume. When you look at the particles of a matter, the particles are those little tiny, smallest possible units of matter. Okay? They're even smaller than an atom or a molecule.
Oh, you can't see
them. So they're
like
little tiny and you can't see them. The particles of a solid vibrate in place. They're held in a fixed pattern, and that's what makes the object solid. Okay? Does anyone know another state of matter? Yes, very good. A liquid. Liquids have no definite shape. They take the shape of the container, but it has a definite volume and a definite mass. Can you name or write down three different types of liquids?
I was going to give them a hint.
Try it.
Exactly.
Very good. Water was mentioned. Water takes the shape of the water bottle.
What's
Coffee
here? There.
is my favorite. Coffee. I have coffee every morning. It takes the shape of my cup. What are some other liquids that we have over there, Miss Mays?
One that we're very familiar with these days, because it does change shape. So is this liquid?
It is a liquid.
Yeah.
If I were to pour those liquids out on the table, they'd run around and they'd fall or they'd spill. I don't think our parents would be very happy, so no pouring liquids on the table. Liquids have particles also. Miss Mays found glue.
Yeah.
Glue is also a liquid. We have rain, we have water droplets, and all of those other things that we mentioned before. Liquids particles slide past one another in that space. They're close together, but they're free to move.
Yeah.
So, like I said, if we were to pour it out on the table, it would go all over everywhere. A solid doesn't do that. A solid's particles are close together and they contain their shape. They keep their shape. Okay? Does anybody remember the last state of matter? You are right. It is gas. Gas has no definite shape, but it does have a volume. When we talk about the particles in a gas, they're widespread. They're far apart, and they can move very quickly, and they bump into each other. Can you name a gas that you can think of, Miss Mays?
Would steam be?
Steam is water vapor.
When
Yes.
I make tea and the tea kettle starts steaming, is that considered
Very
a gas or a liquid?
I believe that's
It's a
considered a gas.
Yes.
It's the water vapor.
Vapor.
Think about taking your hand and waving it at yourself. Can you wave it? What do you feel?
Yeah.
You
Come on.
feel a gas. So when we're hot, we try to cool off like Miss Mays is doing. We feel that gas. And one way to prove that gas can take up space is get a balloon.
Oh, yeah.
If you have a balloon that's empty, what are you putting inside it? If we blow up the balloon takes a shape. Okay? So those are the 3 states of matter that we're going to review today. I want to talk a little bit about some properties. I know that in your lessons previously, you talked about properties. Properties are how we describe something.
Oh, yes.
Okay? So let's talk about this dice.
It is blue. Is that a property?
Blue. That is
The
a property.
color. Okay, yes.
Fantastic.
Yeah.
Property is the color. What else?
It looks like it has lots of sides.
It does. It has lots of sides.
And is it squishy or is it hard?
It is squishy.
See, I can
It's squishy, but it still contains its shape. It still keeps its shape, so it is a solid.
Solid.
Very good. Let's talk about some properties of a liquid.
Oh.
Ooh,
Well, water, I think a property is that it's clear.
that is clear. Very good. It's transparent. You can see through
Transparent,
it,
you can
right?
see through it. What's another property? Well,
What if we touch it? When we touch it, what's that
it
property?
would be wet.
It's wet.
Yes.
Very good. It's wet.
And it's like rain has a definite smell. So
Yes.
water has a smell.
So, but would that be the liquid?
Or
would that be
the gas? Things to think about.
Very good things to think about. So if you have your piece of paper, I want you to write down 3 different liquids.
Don't worry about spelling. Just sound it out. You got it. Water.
Spelling isn't what counts right
Yeah.
now.
Right now we want you to get your ideas on paper.
And effort. There we go. Perfect. All right, so let's go to gas.
Okay.
Gas. Gas is over here. It has no definite shape or volume. It's things that we can feel, and often it's things that we can smell. Smell. I can say that word. Smell. So when you have a vase of flowers or you go by, you smell those gases that the flower is releasing. Remember, the particles of the gas are widespread and they release quickly. So that's why you can smell them. They're allowed to go into your nose. And please don't look at my poor Voldemort drawing. I'm just
I love
saying,
it.
he has no
I love
nose. So, all right. So we're going to use these 3 states of matter to do a science experiment. But let's talk about them first. We're going to use soda. What category does the soda fall in? Let's think about those properties. Does it have a definite shape? I don't think so. If I poured it out on the table, it wouldn't hold its space. Does it take the place of its container?
Yes.
It does. It takes the place of the container.
Yes.
Very good. So, is it a liquid or is it a gas?
I say liquid.
I say liquid too. Good job,
Okay.
guys. It is a liquid. That is one of the things we're going to use for our experiment. Let's look at this. This is another thing. You could do this experiment at home if you had a clear glass and some soda. What state does this fall into? Is it a solid, is it a liquid, or is it a gas?
I think it's a solid because it's hard and it doesn't change shape.
It's hard and it doesn't change shape. It has a volume, and if I were to weigh it, it has a mass.
Yeah.
Okay, so yes, it is a solid. The last thing we're going to use for our experiment are raisins.
Oh, do I get to eat them?
You don't get to eat them, but you can feel them for a second.
Oh, yes.
No eating raisins.
They're a little mushy.
They are a little squishy.
They're squishy, yeah.
But does the raisin have a shape?
Well, it does.
It does.
It does.
It
I can
does.
change the shape, but it
Kind of,
doesn't.
sort of, but it doesn't change from a raisin.
No, it
Okay.
doesn't lay flat.
So
well, I could, yeah.
you could smash
Smash
it
it, but
and
that's
change
not
its
right.
properties altogether, but we're not
Yeah.
going to do that, Miss Mays.
Okay.
It is a raisin. It holds its shape. It may be squishy, kind of like my dice. Remember my dice was squishy? But it's still a solid. So it keeps its shape. It doesn't weigh very much, but it
No.
would. And it has a volume. Okay, so I'm going to ask Miss Mays
Okay.
to go over
I'm going to put these.
to another table, and we're going to do the experiment in two different places. One where you can see it up close, and one where you can see what I'm doing. The experiment takes a little while, so we're going to review some other things as we go along, but just bear with us and we'll see how it works. Again, you can do this experiment at home if you have some soda, a clear soda, or it would work with a dark colored soda, but you wouldn't be able to see the raisins very well. It works best with a clear soda. Are you ready, Mrs. Mays?
I am ready. Are they ready? Can they see me?
Actually, you know what, Miss Mays? I'm sorry, I made a mistake.
Okay.
I want to go over, and you have to come back. I want to go over the procedure of our experiment first.
Okay.
And then I'm going to make you make a prediction, because that's what scientists do. Scientists
right.
predict. And then we'll do the experiment. I'm so sorry. I got ahead of myself.
This happens.
All right.
Okay.
So the procedure would be that we are going to take the soda. We're going to pour it into our glass. Then we're going to add the raisins to the
Okay.
glass. We're going to watch all of our states of matter, and we're going to watch how they interact with each other. What does interact mean?
It means like talking or playing together.
Yeah.
It's like working together.
Exactly.
Yeah.
That's how we're going to work on that. We're going to watch it. So before you do that,
I have a question.
Okay, question.
I don't see the gas. I don't understand. What's
we're
the
not
gas?
there yet, Miss
Oh,
Mays.
okay.
So before we do that, I want you to predict. Well, you know what? Let's go and talk about what you just said.
Okay.
We talked about the properties.
Right?
We did. We have a liquid, and we have a solid, and we have another solid.
Right.
Are there any other states of matter that we're going to use?
Well, you said that we were going to use gas, but I don't see any gas. I don't understand. Are we going to...
Very good.
Are we
The
gonna-
gas is what we call carbon dioxide. Thanks for keeping me on track, Ms.
Oh,
Mays.
there we go.
It is the carbonation that we have inside the soda. The
Oh.
carbonation, have you ever shaken up a bottle of soda?
Yeah, that my mom was not.
What
yeah, no,
happens
yeah,
when
it
that
makes a
happens,
big
Miss
mess.
Mace? It makes a big mess.
Don't do it. Your
And
mom
the
won't be happy.
reason is the gas is escaping. You woke it up and you made it, kind of like we woke up our brains, right?
Yes.
We woke up the gas inside the bottle, and it is now escaping. Remember, our particles of gas move very quickly. So
That's
when we make it and we open the bottle, you're going to see the gas.
Oh, I can hear it.
And do you see how it changed?
Oh,
spill a little bit. Oh, I almost spilled.
She almost made a mess, but that,
do you see the gas?
So that was the gas that we're
The
going to work with.
gas, you're
Okay.
right, is the carbonation and the carbon dioxide that's inside the soda. Thank you.
Okay.
Very good. So yes, we're going to use all three states of matter
Okay.
in our experiment, and we're going to watch them interact together.
Okay.
Okay, so let's look at our graph real quick. It says, what will the solid do when it is put in the liquid with the gas? That was a fancy way of saying, what will the raisins do inside the 7-Up? What do you think it's going to do, Miss Maids? Do you think it's going to explode? Do you think it's going to sink? Do you think it's going to float? Or do you think it's going to dance, go up and down? The raisin is going to dance. Now, I've asked some friends in my area here, and we've already added their guesses to the graph.
Well,
What do you think?
I would love it if they would explode, but I don't think that's going to happen. So I'm going to say sink, because they have matter, so they weigh. So I think we're going to put it in there, and it's just going to go to the bottom.
Okay, that's a
So
good
that's my
guess.
prediction.
Here, I would like you to add your
Okay.
prediction to our graph.
Sink.
Okay,
Boom.
perfect.
There we go.
So, looking at our graph, how many people do you think have done or made a prediction, like scientists do, on our graph? How do I figure that out?
I think if we add up all the X's, that will give us the total amount of people that have told you their prediction.
There you go. Let's count and
Okay.
see.
1, 2, 3, 4, 5, 6, 7, 8,
9, 10, 11, 12, 13. So 13 people have looked at our graph. 13 people have made a prediction that scientists, like scientists do. And now we have to test our prediction. But I want to ask a couple questions about the graph first. Let's do a little more math.
Okay, cool.
Okay.
Love math.
So how many more people voted for sink than float? How would you do that math?
Sink, then float. Well, I could compare them by
Right.
just saying there's way more sinks, not as many floats. And so this would be the same, so it's 3 more.
Very good. 3 more people chose sink than float. I would have done a subtraction problem.
Oh, yes.
I would have counted all of the sink and subtracted all of the float.
Nice.
So 6 minus 3 equals 3.
Yes.
It's the same answer.
Yes.
So you can do math many different ways and get the same answer. What
Nice.
works for you? All right, so let's see. How many more, I'm going to try to trick you. How many more people chose sink than float and dance?
Then float and dance.
Yes.
I think that and is important. Float and dance. So I have to combine those. So I'm going to go 1, 2, 3, 4, 5. So that's the total of float and dance, but I'm supposed to compare it to sink.
To sink.
So that's 5, and this is 1, 2, 3, 4, 5, 6. So I'm going to use your method. 6 minus 5 is 1.
Fantastic. Great
Okay,
math.
nice.
Great math. All right. So let's do our, I realized before we go on, I don't have a title on my graph. All graphs need a title, and they all need a question, but you're not going to know the title until the end because it gives away the answer. So I'm not putting a title on it.
I'm wondering if the kids at home should write down their prediction right now.
Absolutely.
On their paper before we do it.
Absolutely.
Explode,
So write
sink,
down
float.
your prediction. What do you think is going to happen with our raisins?
Okay.
Are you ready? All right, let's see how we're doing. So
Okay.
we're going to go and do the
Okay.
procedure
I'm
again.
going to go over there. This
Okay, remember that our materials are soda, a jar, and some raisins. Miss Mays is going to tell me when she's ready.
Okay, I am here.
All right, so the first thing I want you to do, Miss Mays, is open the soda. Open it slowly, because you saw mine was almost about to explode.
Yes, I hear the gas coming out. The carbon dioxide.
Carbon dioxide, the
Carbon
carbonation.
dioxide, the bubbles.
Fantastic.
I'm-
The liquid and the gas are all in one.
And I see a lot of bubbles. Lots of bubbles.
Yeah, mine's spilling, but you know.
I'm not
Hopefully
even
it-
done opening it. There we go. Okay, mine is open, Miss Grove.
All right, fill it up. Oh, about 3/4 of the way full. Let me know when you're ready.
Okay, 3/4. I'm trying to get there. I didn't want to spill.
I think I need a little bit more in mine.
Okay. Okay.
Can you see the gas, Miss
I
Mays?
can. I see the gas. The bubbles are going up.
Yeah, and if you were to put your face real close, you would feel a little bit of a splash from the bubbles, right?
Oh,
you could feel
wow.
the gas coming out.
Oh, you do?
There you go. All right, so the next thing you're going to do, Miss Mays, is you're going to take about 10, 15 raisins. You can estimate. It's okay. And put them inside your jar.
Let's see, 3, 6. Okay. I put them inside the soda.
Very
Okay.
good. All right.
Wow.
So if you're watching the raisins that Miss Mays put in there, what are the raisins doing?
Woo! They
What-
are.
Well, don't say it yet. Wait.
I'm like, oh my
Let's
gosh.
think. Let's watch a little more. Did the raisins sink, Miss Mays?
They did?
They did, but did they stay down?
No.
They didn't stay down. Why didn't they stay down, Miss Mays?
The bubbles are carrying them up to the top, and then when they pop, they sink back and go back down.
That is exactly right. The
Oh my-
bubbles
it's so
are
cool.
from the gas. The gas in the raisins help the raisins have more buoyancy. They help them to float. What does this remind you of, Miss Mays?
It reminds me of when I'm in the pool and I have my
Yeah.
floaties on.
And you have your floaties. If you don't have your floaties on, you bob up and down,
Yes,
right?
exactly.
You bob up and down to get air.
Yes.
Well, think about that. When you're in the swimming pool, you fill your lungs with air, and it helps you with
Nice.
buoyancy. Well, that's what the gas is doing to the raisins. The gas is sticking or collecting to the raisins. It's floating up to the top. It's popping. That means there's no more gas. It's escaping, and then it goes down. Then more gas will collect and make the raisins come up and down. Are our raisins exploding?
No, the raisins aren't exploding.
The raisins are not exploding. So even though we had a couple people choose that, they weren't exactly right. But think about what scientists do. Scientists do experiments all the time.
Yep.
And their guess is not always right. Let's look at the next one was sink, Miss Mays. Most people said sink, and they did sink, but did they stay sunk?
Nope, they go to the bottom and then more gas attaches to them and it carries them back up.
Very good. The next one we had on our graph was float. And I don't know if you saw it, but when I put them in, a few of the raisins floated
Stayed
for a
on
little
top,
while.
Yep.
But then they had a little more density and they went down to the bottom. And now what are our raisins doing, Miss Mays?
They're going up and down, I guess, dancing. in
They
the
are
water.
dancing. The name of this experiment and our graph is called Dancing Raisins.
Nice.
I was afraid if I put that title on my graph, you guys would have guessed what it was. And it would have changed your prediction, and I didn't want to change your prediction. So I'm going to review and write the results of our experiment. So if you're ready, get your pencil, boys and girls, and you can write what the results were too. Thank you, for your help, Miss Mays.
Sure.
You're awesome.
So I'm going to come back up and help. Is that correct?
Sure.
Okay. I'm going to leave.
Not sure I can write on that. Let me think. Let's put it back over here. I'm sorry for that change, but I didn't think I could write on that bulletin board. All right, so what was the title of our experiment?
Dancing raisins.
Dancing Raisins. Is this an experiment you can do at home?
Yes. With the
I think it
permission
is, too.
of your parents or grown-ups or whoever you're with.
I agree. Dancing Raisins. So, can you tell me what we think our results were? How are the raisins the gas and the liquid all interacting together.
Wow.
I think you should write your results first,
Yes.
and then we'll check them with what Miss Mays and I believe. If not, you can write them down with us as you want. Do you have your ideas down? All right, what do you think our results were? How are they interacting?
Well, they're working together.
They are. I should probably start with all of our matter is working together. What exactly was the gas doing?
The gas is attaching to the raisins and lifting, and then, lifting the raisins up to the top.
I don't really know or remember how to spell attaching because I'm not a very good speller. So I'm going to do a synonym to attach, and I'm going to write stick.
Oh, they are sticking, yes.
Sticking to the raisins. And what form of matter were the raisins?
The raisins were solids.
That's right. So the gas
Yes, solids.
is sticking to the solid, and it's doing what?
It is raising them to the top.
Yeah.
Because where the
it's
gas is
helping-
released, yeah.
It is raising them to the top. Raising the raisins.
Raisins, yeah. Yeah, raising the raisins.
The top of what?
Of the soda, or the,
Right,
yeah.
or
so
the
we're this-
liquid.
yeah.
Top of the liquid. And then what are they doing?
Then once the bubbles pop, the gas is released and they sink to the bottom because they have nothing holding on to them.
Good job. They sink the bubbles. See what else? Pop.
I know, it's a big sentence. It's a big
And-
sentence, yeah.
The gas is released. Good. I can't spell that word. Miss Groth didn't do so good. R-E-L-E.
It happens.
A-S-E-D. We all make mistakes, don't we?
Yep.
Is it okay to make mistakes, Miss Mays?
Absolutely, that's proof that you're trying and learning.
And that's how we learn. We learn from our mistakes. So the bubbles pop and the gas is released. And then the raisins go down again.
Sink.
Or sink. And I'm running out of room, so I think that's where I'm going to stop. And then it happens all over again. I'm going to write all over again. So that is the results of our experiment. Now, boys and girls, you have lots of things at home that you can try an experiment similar to this. Similar means the same, okay? You can try a different liquid. Try some rice. Try some pebbles. If you don't want to use food, try pebbles. Put little small pebbles in there and see if the raisins, or the pebbles, sorry, the gas will collect on the pebbles, that kind of thing. So if I used water, do I have that form of matter in my water?
Well, not that water, but if you used the bubbly kind of
water.
bubbly water.
That is one of the
wonder.
kind of stipulations, maybe, is if you have to have a gas. You could actually add baking soda to your gas too, by the way, or to your water to maybe make some gas. But again, boys and girls, remember that you must have permission with your parents to do this at home. All right. So we went through a lot, Miss Mays. We did a really good job.
You did a
What I
great
really
job,
want to
yes.
do is review
Yes.
our vocabulary. So maybe we want to move our graph. And I want to review our anchor chart real quick. Oh, nice, Vanna.
Yeah.
All right, so let's review our states of matter. Okay, we have 3 states of matter. We have a solid. It definitely has a shape. It has mass and it has volume. It has weight and space to it. The particles in a solid stay close together. Remember, the particles are those little tiny things that we really can't see. They're even smaller than atoms and molecules. They stay together. They're held in a fixed pattern, and that is what makes a solid shape.
Yeah.
okay? Another form of our matter is liquids. Liquids have no definite shape. They take the shape of their container. But if I were to put it in a container and then try to weigh it, it does have volume and mass, takes up some space. Good job, okay? The particles in a liquid are a little bit further apart. They have a little more space. They slide past one another and move, and that's what makes it have no particular shape. It just can pour onto the ground. Our last form of matter was gas. Gas has no definite shape or volume, but it's there. We can make it appear.
So like when you blow bubbles.
Yeah.
You do the bubbles and you go, you're putting gas into it and then it carries it up. Like the bubbles.
Exactly. Can you think of some other forms of gas that help, especially here in Albuquerque? I'm going to give you a hint. We see them every October.
The hot air balloons.
The hot air balloons.
That's how they float around.
Very
Nice.
good. That
Yes.
gas from is the hot air.
Mm-hmm.
The fire heats up the air, and the hot air rises. So those are things that we see here in New Mexico that also have to do with matter, gas, and solids. Very good. All right, so the next time we meet, I'm going to go over the phases of change in matter. And I don't come every day, so you'll just have to wait and maybe
I think it's next Tuesday, I think. But
look at all of the APS at home,
Yes.
and then you can find us doing phases of change. Before you do that, I want you to make, or while you're waiting, I should say, make a list of all the solids you can find, all the liquids you can find, and all of the gases. And then make a prediction. Take a pencil and circle the ones that are going to change. Okay, so that's your assignment until you see me the next time. We're going to take a quick break, and then Miss Mays and I will be back to do math.
hi guys, all you mathematicians out there. Now we're going to, she did a lot of cool math in that with the graph and stuff, but we're going to do some more number work, some counting, and hopefully some games we're going to play. But first, we're going to take like a little brain break because you just did a bunch of science. So you're going to stand up again. We've got to take a brain break, and we're going to put our feet, once again, shoulder width apart. But this time, we're going to count backwards not backwards. We're going to count forward, but from 7 by tens. A little harder.
7 by tens.
Well, you're going to, yes, we're going to start at
like
7.
7 and then 17. Is that what
yes,
you mean?
yes.
Okay.
So
Okay,
yes,
I got it.
because we got counting by tens down if you start with 10.
It's like counting money.
Right, but we're going to start with 7.
7.
And we're going to go and we're going to do crossovers. Well, and make sure that our hands cross the midsection and touch our knee. And we're going to go slow and count backwards, like I said, by tens, starting at 7. Okay?
Right.
Okay, so let's do this.
Go.
7, 17, 27, 37, 47, 57, 67, 77, 87, 97. Can you go farther? 107. Yes, crossing that 100 is hard. Good job, Miss Growth.
Thanks.
Okay, so this other one we haven't done, and I don't know, it's called push up the sky and push down the earth. So you're going to like kind of stretch your arms like that. Let's wake it up. And now you're going to put your right hand, and you don't totally straighten out your arm, but you're going to act like you're pushing up the sky, but at the same time you're pushing down the earth with the left hand, and we're going to bend our knees.
Oh, wow.
So yeah, you're going to.
It's a lot of things to do.
So yeah, this, and then you're going to come together and do it like that. Do you see?
Okay.
So you're going to push up the sky.
I'm going to have to really think about this.
Yes, and it's waking up your left brain and right brain. You're going to be ready for some math. And we're going to count backwards now, starting at 93.
Okay.
But by tens. So I'm going to get some energy in my hands. Okay, yeah. You're going to do this, and can you feel that energy? And now I'm going to push up the sky and push down the earth. Ready? 93. 83, 73, 63, 53, 43, 33, 23, 13. Ooh, this gets hard. And 3. Oh, nice job.
I had to really think.
It
to
is
do
hard
that.
to count backwards by starting at different numbers. So be sure to practice that at home because it does make it easier to subtract. So I saw that I think it was Miss Maggie talked about digits a few weeks ago. And so what is a digit? Do you remember what a digit is?
A digit is a number, right?
It is
And
a
where
number.
it is?
It's a number between 0 and 9. Digits make up numbers.
0 to 9.
0
A
to
digit.
9. Yes. So I thought we should review that. And then I wrote down some digits. A 5, a 4, and a 7. Now we're going to make the biggest number we could make using these 3 digits.
3 digits.
3 digits. What's the biggest number we could make?
I think I know.
Okay, do you guys think you know? Okay, so Ms. Gross, what do you think it is?
So if it's got 3 numbers, that must mean that I'm in the hundreds.
Yes.
In the hundreds. So the biggest 100 that I would have would be the 7. The 7 is the biggest number.
Okay.
700. Now I have to look at those other 2 numbers. I have to look at the 5 and the 4. Which one's bigger? And I'm going to put it in the tens place, right?
Yes.
I say the 5.
There we go.
And the last one in the ones place would be the 4.
So, oh, sorry.
Want some tea?
Of course, 750. Oh my goodness, there's 2. Of course.
We thought it was going to work.
Yeah, we thought we would be sticky. Here's some tape. So 754, is that what we came up with?
It is 754. Really?
Yeah. I think part of it is all the lotion and washing of my hands, unfortunately.
Well, we have to be safe.
Yes, we have to. Because we're going to move them around.
Okay.
We're still going to move them around because now I'm wondering, can we make, what's the smallest number we could make with these digits? Because we're making 3-digit numbers. This was the biggest. What's the smallest number we could make?
I think they should write their answer down. Write your
Okay.
answer down first, and then we'll check it. Okay.
Okay. Well, you went from the big, you said what's the largest because we were making the largest number.
Right.
Is that how you're going to do it for the smallest?
I would start with the smallest, or the one that's the least.
So that would be the 4.
That would be the 4.
So we're going to move that over here. And
Then I'm going to look at the 7 and the 5, right?
Uh-huh.
And the 5 is smaller than 7, so I would put the 5 in the tens place.
There we go. And last,
Would be the 7.
and it's going to need tape, I can tell. Okay, so now we have made a 3-digit number, the smaller one, 457. 457. Notice I didn't say and.
You
Say
didn't.
and.
Right.
It's a habit, but I'm practicing. 457. Now we're going to try to make and represent 457 as many ways as we can. Like
Wow,
the
that's
number,
a big number.
it is, but I think we can do this.
I do too.
So I know that many, that's not going to step. Many of you have done this before, like I said. So what's one way we could represent this number? I'm just going to draw it. Do you have any ideas?
How about with base 10 blocks? Hundreds, tens, and ones?
Base 10 blocks. I love base 10 blocks. And so I'm asking, how many base 10 blocks in the hundreds do I need? How many hundreds are there?
4.
4. So I call them flats. 1,
Oh, flats, good word.
2, 3, 4. So I have 4 hundreds because there is 10 tens in 100. So really, it's
And
like
they're a flat square.
Yes, they're a flat square if you've seen them at your house. Or I mean at school, in your
I bet
classroom.
you have.
Yeah. And then we have 5 tens. Right? So I make tens with just So we have 10, 20, 30, 40, 50. Is this what you had in mind with
That
base
is
10 blocks?
exactly what I had in mind.
And
Thank you
how
very
many
much.
ones?
We have 7 ones.
So 1, 2, 3, 4, 5, 6, 7. So now we represented it using base 10 blocks. Good job, Ms. Grubb.
Awesome.
So there's other ways that we can represent 457.
Do you guys have an idea? I think we should write the word.
The words, because now second, third grade, yeah, we're working on that. Even the word 100, we need to learn. My second graders had a cheat sheet for the beginning of the year, but it's time that we learn how to spell these numerals, numbers, digits. So what's that number?
4.
Digit 4. 4. And it's what? 400. So that's where that big word comes in. I'm going to switch markers because I want to make sure that they can see it. And it seems to be dying. Let's see. So 400, and then what is this? When we read it, 400.
We don't say 5. We don't say
No.
405. That would be the wrong number.
That would be, yeah, 405 is a totally different number than 450.
That 5 is in the
50
tens place.
So it's 50. Let's do the 50. 450, oops,
cross that T.
57. I couldn't fit it in. I wrote too big, but I wanted to make sure you guys could read it. So now we did it in words. 457.
And I noticed there's no and there.
There's no and.
That's why we don't say it.
That's why we don't say it exactly.
457.
So is there, now we could do it another ways. There's some other ways that we've done this.
Have you done money?
Ooh, money.
Could we represent
We could do this.
457 in money? I'm sorry if that was
No, we could do that. That is,
We could.
yes, so $457, or would it be $4.57, or?
It depends on how we look at it. If we
Yeah.
look at it as all ones,
Right.
then it would
it's
be $4.57.
So this is hundreds, right?
Right? And so that would be dollars.
$1. So I'm gonna go. Don't laugh at my,
They look like rectangles. I'm good.
yeah. This is my money. Here we go. We're gonna do this. And I think next week when I'm here, we are really gonna count some money.
And they
That's one.
are ones.
Ones,
They're
so-
$1.
Yes, $1.
All right.
That is ones, sorry. So this is 100, 200, 300, 400 cents,
There you
right?
go. Yep.
And now, what currency do we use to make a 50? There's lots of ways,
There's a couple
actually.
ways. But I'd do it the easiest way.
Okay.
If these are tens in base 10, then I would use tens in money.
And the dime is worth 10 cents, isn't it?
There you go.
Okay, so I'm just going to put a D for dime. 10, 20, 30, 40, 50. So there are my dimes. They're really small and silver, but that's going to represent my 50 cents. 450. And then what should we use for the 7?
What currency is only worth 1 cent?
It's
A penny.
The penny, and that's a P. I'm going to use P's. P. 1, 2, 3, 4, 5, 6, 7. I didn't want them to look like D's because that could be confusing. There we go. We got money, got
Awesome.
words.
And I know that they watch this often, and they could do that with every number. that
Every
they
number.
Make. They could make that money if they have some change or
And
some
it's good practice
dollars at
counting
home.
money.
Yep.
Yes. How about expanded form? Have you guys remember
Ooh,
expanded form?
expanded form.
Yeah, we need to do that. So we're going to expand this 400 into a 400 because it's not worth 4.
Nope.
It's 400. And then, do I put a 5?
Nope.
Nope. It's 10, 20, 30, 40, 50.
And we're going to add that together.
Yes. And then there are 7 ones, which all equals that.
450.
457. So we've done it 1, 2, 3, 4 ways. We could also like work with this number and say, do you know what would 10 more be in this number?
Ooh, 400. That's like when we were counting.
Yes, so we would add another 10, like as if we had maybe
How about a different color?
A different color.
Purple?
Yes, let's see if it shows
Or is
up.
that going to show change? Wait, here's red. Red.
Oh yeah, because that doesn't really show
I
up.
read.
So we're going to do one more 10, if I wasn't sure. So we're only, since I said by 10, we're only changing the 10's place. Can't see the red, so, okay.
Can't see the red.
Sorry, guys.
I don't know.
I know, and you can't, so, but I'm just going to go trace it with the black. There we go.
Oh, there we go. That was the
So
one we added.
one more, and so now this number is 467, right?
Yes.
Okay, I'm going to use the back of this. See, I'm improvising.
Tape? Good job.
I'm improvising. Okay, now 467, because that was 10 more. What if we did 100 more?
Ooh, 100 more. That would be the squares, the flats.
We would add another flat. And so 1, 2, 3, 4. Now it's 500. We're just going to reuse this. I need some tape. So instead of 4, now we have 500. That is exciting. Do you want $467 or $567?
I want $567. That's bigger.
Yes.
That's more.
5. So there we go. So now we've totally changed the number, so this would be totally different as well.
I like how you are playing with the numbers, though. We're
Yes,
doing it lots of different ways.
playing with numbers, it can be really a lot of fun. You could also show, so how many hundreds? We could do this for a word. 1, 10s, hundreds. So now that we have a new number, how many hundreds?
5.
5 hundreds, 6 tens, and 7 ones.
7 ones.
So there's lots of ways to show numbers. You could do some equations, some addition equations or subtraction equations. And so try it with a bigger number. Well, I know that you've done like the number, I think 32 with Miss Maggie and some other numbers, but try in the hundreds so that way you can, expand your stuff, expand your digit vocabulary kind of. Digit
game that we can
Yes,
play.
yes, that's
that
what.
will do. Work with this digits.
The digits.
Digits.
So you can make cards if you don't have any cards by just cutting up paper and putting numbers on them. And we did keep it to digits. Remember, a digit is 0 through 9. And the first game we can play, here, I'm going to give you half.
Okay.
The first game is kind of like what we did in the beginning. We're going to make the biggest number.
Biggest number
Biggest
I can
number.
make out of the cards I have.
Out of the cards we draw, right?
Yeah, we draw. I think we
so
draw.
I'm gonna
How many are we going to draw? 3.
3. 1, 2. Oh, and then I try to make the biggest number. I don't have very big numbers. Well, this is bigger.
I have these numbers, but I don't want to start with this one. That one's too small.
Yeah, I need to start. Okay, there we go.
Okay, I think I have my biggest number. How about you, Miss Mays?
I do too. Let's see. Oh,
I have the number 820.
I have the number 211. So
Which one's bigger? Which one's bigger?
The alligator would eat hers.
So I got all of those
So she got all
cards.
those cards, okay.
All right, and
okay,
then you go again.
Let's try it again. Let's see. I feel like I should be able to win.
You can put
Come
them
on.
all in the middle, or you can
Yes.
divide them up like we did.
Absolutely.
However you want to do it.
But you shouldn't be like peeking because you'd be looking for the big ones. So
Yeah,
no one wants
no
to
peeking.
be cheaters. That one's not fun. Okay, I keep getting double numbers.
Wow.
I mean, well, but.
All right. I have the number 120. I got a 0 again.
Oh, I have the number 533. Yes.
So the alligator eats Miss
Yes,
Mays.
okay, I get those. Excellent.
All right, let's go
Okay,
again. Do
one more time, and then we're going to try another game. Let's see.
I'm going to win.
Okay. Oh,
I have a hard time holding these. It's
I
easier
do
if you
too.
lay them down.
it is, and so that way, now look, this has a line, so when you make your cards, do that, so you'll know that it's a 6 and not a 9, because that could be confusing, right? So I like the way Miss Grove did that for us. So, I have to decide, wait. Sorry.
I have a really big number this time.
So do I. I think I'm going to win. Okay, I have 862.
I have 941.
And I can tell because the hundreds are bigger, right?
Hundreds
the
are the
hundreds
bigger.
right there. That tells you she has the bigger number.
941. So the alligator would eat mine, and
Yes.
I get those cards.
So the other game you could play is make the smallest number.
Ooh.
Let's try
make
that.
The smallest
Say,
number.
Make the smallest number. So this time you want small numbers, and Miss Mays is drawing huge ones.
Again, get
Okay.
the 3 cards.
Three
Three
cards,
cards.
and make the smallest number you can.
Ooh, this one's a tricky number, Miss Mays. I have a tricky
Oh,
number.
She does. She put that 0 in the hundreds place. So that means there's no hundreds. So her number is 82, and that's way smaller than 468.
Nice.
That was
That
very
was a
smart.
tricky one.
That was a tricky one.
Yeah, because if I'd have put it in the ones place, I'd have a number
A
that's in the
huge
hundreds.
number,
It's
yes.
way bigger. So I put it there.
Nice. Good job.
All right, so we're doing smallest numbers.
Smallest numbers. Oh, you got to keep
Yes,
side.
I get to keep. That's the way that
Yeah,
works.
I'm sorry,
Just
sorry,
kidding.
sorry. Now I kind of want a 0 because that was so smart. Oh. Okay. Not much I can do with
The
this.
the line goes at the bottom.
477.
246.
Okay, but wait. So, wait, you have 2, so she won again. But wait, before you get rid of that, I want to show, I'm not cheating, I know you won, but I want to see if I had this, I had 277 and she had 246. So the 2s are the same. So then you would go look at the 10s. Which one's bigger? The 7. So the smaller one wins. So she still would win. So
Very
she
good.
still wins. She still gets my cards.
Thank you.
So
What about multiplication?
Yes. So if you wanted to use these cards, like I said, once you make the cards, keep them because there's so many games you can do. So let's do that. Let's each draw this, is multiplication top it, okay, for kids that are already there. So you're going to do, I'm going to flip over 2 cards, and I would multiply those. 8 times 8 is 64.
2 times 7 is just like a double. It's a double
It is.
7. It's 14.
So you can decide if you're going with the biggest or the smallest number. I say biggest. I'm just kidding.
So she would have
So
won
I would
that
have
one.
won, yes.
But you can play lots of games that work on your math facts.
Yes, keep in mind that these cards would come in very handy to work on your math facts. You can you can do subtraction, addition, and multiplication.
Very good.
Yes, so just to wrap up, we did our number of the day, 567. It was started out as 457, and we did 100 more and 10 more, and we wrote it wrote it, not necessarily wrote it, we represented it in many ways, and you can even come up with more. So next time we're together, we'll do another number, possibly some more games, and I'd like to review some subtraction.
Oh,
yeah, so
nice.
subtraction would be fun.
So we'll do some more phases and matter, changes,
Excellent.
phase and change in matter, and we'll do some more subtraction using digits maybe.
Yes.
But we really, really enjoyed doing this with you guys
Yes,
today.
thank you for joining us.
Yes, so remember, the games are just like doing all your math.
Mm-hmm.
Practice your math with the games. Practice your math with writing it down,
Absolutely.
representing it,
In different
and doing
ways.
all those things. We want to thank you again for joining us for At Home with APS. We hope that you enjoyed your lessons, and we'll be back with you again another day.